Good morning to you all. Welcome at this webinar for commercial audio and system design. I'll be your host for today for this webinar. My name is Martijn van Overveld. I'm a marketing manager for EMEA, amongst others, responsible for commercial audio. So the presenter said Jan-Pieter Smolders, application engineer for public address, commercial audio, public address voice alarm. With a wide knowledge of our systems and applications, and as such also the right person to do this presentation today. Let me give you a couple, before I give the floor to Jan-Pieter, let me give you a couple of annotations for what the presentation is about. Can you move to the next slide, Jan-Pieter? Yeah, okay. Yeah, just a couple of things on the objectives and the topics of this presentation. So basically, it is all about system design of commercial audio systems. So what we will do today is give you an overview of the systems that we have ready for you for applications in commercial audio. So Jan-Pieter will go through some examples then and how to design, and last but not least also will give you more insights on 100-volt systems and the basics in that. So I don't want to steal more of your presentation time here, Jan-Pieter, so I'll give the floor to you. So there you go.
Okay, thanks, Martijn. Welcome, everybody. Yeah, we'll start directly with the commercial audio applications. So first topic, what is commercial audio? Well, Bosch has a lot of different devices which can provide different control methods and speaker types to create a nice atmosphere. Basically, yeah, you will enhance the customer's experience by creating this atmosphere. And how do we do that? We do that with nice foreground to background business supporting music, and the possibility to broadcast advertisements, voice announcements, and speech. So that is what we mean with commercial audio. A commercial audio system, it can be a standalone system. So for instance, in one system in a shop, but it can also be extended and connected to a public address voice alarm system, which is present maybe in a mall or in a bigger environment. So it will all also next to the nice environment. Also, it will add some safety to your environment where you are. If you look at the different solutions that we have here from the left to the right, an entry level, extended level, and professional level. Now the entry level, that is for smaller businesses like an office, small office, a restaurant, a bar, or retail shop. Then we're talking about a system that can address 1 to 2 zones, easy to install, easy to use. Then the extended systems, it's a bigger supermarket, maybe a big store or a mall. Then we're talking about systems that can address 2 to 6 zones, but also have 2 or more channels, 2 or more amplifier channels. That means that, for instance, if you have a system with 2 zones, then in one zone you can have, for instance, music, and in the other zone you can make an announcement or whatever you like. Then the last one, the professional system, we're talking about planar matrix here, is for bigger environments, clothing store, conference, hotel, boardrooms, fitness center. So it's a multi-purpose system. We're talking about 8 zones here, up to 8 zones. And well, it will be important to have a good quality of music, good audio quality. Now this part, the professional part, we will do in part 2 next week. Okay, commercial audio systems. If we look at the Bosch solutions, the entry-level application, we are looking at planar easy line. This is a small system which can address 1 to 2 zones, a single amplifier, so a single channel. If you look on the picture here on the left, we see 2 mixer amplifiers. The top one, the 1ME. It has 4 microphone line inputs, 1 background music input. It's 1 channel, 1 amplifier. You can address 1 zone with a built-in amplifier of 60 watt, 120 or 240 watt. And below that, the PLE 1MA, one channel mixer amplifier, can address also 1 zone, but it has 3 BGM inputs plus a priority input. So this mixer amplifier you can connect also to a voice alarm system with a priority input 400 volts, so you can connect to a simple loudspeaker line that is already in your venue. It has also 3 different versions, an amplifier of 30, 60 or 120 watt. Next to that, we will see the PLE 2MA, so it's a 2-zone mixer amplifier. On top of it, you will see 2 call stations. The left one is a 1-zone call station or an all call. You can address 1 zone. And next to that, we have a 2-zone call station, the 2CS, which can be used in combination with the 2MA. The 2MA has 6 microphone line inputs, 3 background music inputs, also a priority input. It's a 1-channel system, 1 amplifier, and it can address 2 zones with a built-in amplifier power of 120 or 240 watts. The next in line is the planar easy line is the 10 M2. This is a mixer where you can connect 2 external amplifiers to. So this is a 2-zone system, but with the possibility of 2 amplifier channels. So that means if you have music in 1 zone, for instance, you can make an announcement in the other one, like I just already said. Now, if you look at the picture here, on top of this system, we see a wall panel. This is a nice feature. You can mount it into the wall, and you can make a selection of your BGM channels. This system has also 3 BGM inputs, and you can also make a selection of the zone where this music should be audible in, zone 1 or zone 2 or both. Now next to it, we have the 2-zone call station. You can also use a 1-zone call station if you don't need to address the individual zones. You can add 2, or you can connect 2 external amplifiers to this. You see here the planar power amplifiers, 120 watt or 240 watts. But you can, of course, connect any amplifier that you would like to use. So for instance, if you have already an installation where you have already amplifiers installed, you can just easily use this mixer and connect it to those amplifiers as well. Now, if you go to the extended applications, we have the planar all-in-one solution actually. This is a 6-zone device, so you can address 6 zones. And you can also use an external amplifier to the system. So you can also use this in a two-channel mode. If you look at the picture, you will see the call stations with the possibility to address 6 zones individually. A remote control unit on top of it where you can make a selection of the zones. It also has an external input, as you can see, an XLR and a mini jack. So you can control this unit also, the device also remotely. It has a built-in amplifier, 240 watt, and it has an integrated music unit. So there's a USB and an SD input that you can use here as well. Our final application, the professional application, you see here this system. It's called Planar Matrix. It has an 8-in, 8-out mixer, the small unit you see on top. And it has 2 versions of amplifiers, 125 watt or a 220 watt amplifier. Now these amplifiers have 4 amplifier channels inside, so each channel can handle this power. So if you would buy a 4 by 125 watt amplifier, you have 4 amplifier channels of 125 watt. That means 500 watt in total. Now, if you want to use this system in all zones, with all zones connected, you need 8 amplifier channels. You need 2 of those amplifiers, as you see here in this picture. On top of this system, you see the call station. You can select zones with it. You can also program it to make an all zone button to select. And next to it, you see the wire panel. It's the wall panel, sorry. This panel you can use to select music sources and the volume, or you can use it to select one of the 4 inputs that are available on the mixer. Now, a nice thing about this system is also that it has DSP, digital signal processing inside, so you have a lot of possibilities to well, enhance the sound actually. Now the design. If we look at the design of a commercial audio system, what do we need? First of all, we need to know what the requirements are and for which type of application it's going to be used. So start with the first question, how many zones are required? If we have an application with 1 to 2 zones, then we can use a planar easy line mixer amplifier, we've seen. Or if you need 2 to 6 zones, yeah, we at least need a 2-channel mixer for planar easy and some power amplifiers, or we can use the planar all-in-one, which has 6 zones, and then if we need more zones, 4 to 8, then you need planar matrix. Then another important choice you have to make is the amplifier power. How much amplifier do you need? This is depending on the loudspeaker load, so the amount of loudspeakers. If you have a large room, you need more loudspeakers. It could also be that you need loudspeakers with which will use or which will require more power. So depending on your loudspeaker choice, you have to decide on how much amplifier power you need. Some additional requirements could be the amount of music sources you can connect to the device. You can have 1 or 3, or maybe it has to be built in, like we see in the all-in-one. Does it have to be uninterrupted? So if music is playing, it should not be interrupted when you're making, for instance, an announcement. Then you need at least a 2-channel system. So a system with at least 2 amplifier channels. Control, if you need remote control via wall panel or wireless maybe. Maybe you need to enhance the sound, you need DSP. Also, it could be that you have maybe a conference in hotels. You have some conference rooms that you would like to combine. If you have a bigger conference, that you can combine 2 conference rooms to 1. So you would like to use presets maybe. Or you might want to integrate it with a third-party application like AMX or Creston maybe. And then we're talking about, from the wireless part on, we are talking about the planar matrix system, which we will be talking about in our second part of this webinar next week. Now, if we're looking at loudspeakers, there are different types of loudspeakers. We took some of them. You see here, ceiling, surface, or pendant loudspeakers. If you look at the left column, ceiling loudspeakers commonly used in offices, restaurants, or supermarkets. And if you look from the bottom to the top, you can see they go up in performance. You can have a simple ceiling loudspeaker like the LHM or the LBC 3090, and then you go up, you see the LC6. Now this is a special one. You can see there's a big ceiling loudspeaker in the middle. That's a subwoofer, so very good for the low frequencies and for satellite speakers. And then if you go up again, we have the LC2 and the LC20. These are premium loudspeakers, so very good frequency response, very nice for a good audio reproduction. Then if you look in the middle column, surface mount loudspeakers, which we'll see in, for instance, bars or retail stores. They have brackets or a way to mount them to a wall. Entry level here, the LB10 or the LB2, which is already a very nice loudspeaker. And if we go up, we see the LB6, this one over here. The LB6 has also a subwoofer, the subwoofer in the middle, and 4 satellites. And left on top, the LB20, very nice cabinet loudspeakers, full range loudspeakers in different sizes. And then in the column on the right, pendant loudspeakers. If you have, for instance, very high ceilings and you don't want to use that many high power loudspeakers in order to be able to have enough sound pressure level, you can also use pendant loudspeakers, so they're a little bit closer to your ears. The LP6, for instance, you can use for that purpose. Then on the right side, you'll see also some solution with subwoofers. If you need a lot of bass, if music in the for instance in a retail store or whatever a clothing store, and you need a lot of bass, then you could add to your system maybe an LB20 subwoofer as a big loudspeaker, or you can use the LC6 or LB6 systems, subwoofers with the satellites we also have for those systems, or the LC2 subwoofer. That's a big subwoofer, which you can use also for this purpose. Now, if you look at an example, how to design a system, we're going to look at a fast food restaurant. It's a one-zone system. Now, what are the requirements? We have a restaurant with an area of approximately 150 to 250 square meters. We need to make voice announcements. We also need separate tone control via voice and music for voice and music. And we need a priority input so it can be connected to a voice alarm system as well. And 3 music sources. Now for this application, we are going to use premium ceiling loudspeakers. So how does that look, this solution? The premium ceiling loudspeakers, we will use 6 of them, and we have chosen the LC2 PC30 G64 for this application. And we are going to use the PLN2MA, so a 2-zone mixer amplifier, which has 3 BGM inputs. Now the required power, we are using 6 LC2 PC30 loudspeakers, they're 30 watts. So in total, we need at least 180 watt of amplifier power. So this PLN2MA 240, which is a 240 watt amplifier, will be sufficient. Then in order to make announcements, we will use the all-call call station you'll see here on this picture. If we look at the installation, it's very straightforward. We have the device on the top right with the call station connected. 2 zones, 2 outputs. On each zone, we have 3 of those loudspeakers connected. And there's also an option, for instance, to add an additional loudspeaker, for instance, in the restroom. That's easily done. We are using 100-volt line, so you can just tap it off somewhere from that line and connect it directly to where you need it. Now, a second example, we have supermarkets, and we need up to 6 zones for this application. So it's a big supermarket, 500 to 800 square meters. We need voice announcements, messaging alerts and special offers, background music, maybe tuner, MP3 player, control via the wall panel, and 6 independent zones. the product we select for this is the LC6 compact sound system. So we are going to use the subwoofer with 4 satellites, and we use 2 of them. And there's also a possibility to use this satellite speakers independent version, but we've chosen the ceiling version. Then we connect that to the all-in-one amplifier. So we have 6 zones, 240 watt. It has a tuner and a USB SD player. You have 3 additional music inputs, docking functionality on this device, and 6 microphone inputs, of which 2 have a line option. Now, docking, if you don't know what docking is, it's like when you have music playing in a zone and you want to make an announcement there, is that your announcement, when your announcement is live, the music will lower its volume. So the music is still there, but at a lower volume. And then when your announcement is over, the volume of the music will return to its initial value. So it becomes louder again. Now the option of this device, of the all-in-one, is to add an external amplifier. For instance, a plain easy-line power amplifier of 240 watts. It will match the internal amplifier of this unit. So in that case, when you connect an additional amplifier, you will have 2 amplifier channels. So you will not interrupt music when you're making, for instance, an announcement to zone 1. Then the music in the other zones will still continue. So be aware of that. If you need this type of application, you need music at all times, not interrupted. Make sure that you have a second amplifier channel available. So add an additional amplifier to it. Now for the announcements, we need a call station. We have a dedicated call station for this system, 6 zones, as you see here on this picture, and a remote control panel. This is a wired panel. It will take over the control of the device itself. As you can see already here on this picture, you can make a zone selection. You can select your music source. You have a master volume, and you can also connect here an additional microphone. You also have a line input. You see here this mini jack, a microphone to the XLR input. So that's also a possibility here. If we look at the picture, how it's connected, we have the 2 subwoofers in the middle of the room here, and the 4 satellite speakers around it. Here is the all-in-one wall panel, which you can also use at another location. If you have this in a separate room, maybe you can use the wall panel, maybe close to the bar, or sorry, to the close to an office in your supermarket or wherever you want to use this. In addition, you could add more zones. We have now 2 zones in use, but you can also add zones, for instance, for the restrooms, for the office, for the storage, or the outside entrance maybe, and then you have a full 6 zones used of this system. Okay, now in order to clarify how we are connecting these loudspeakers, you have to know a little bit how a 100-volt system works. It's important to know what impedance is. What is the impedance of a system, a loudspeaker or an amplifier? Now, the loudspeaker impedance refers to the load a loudspeaker puts on an amplifier. This is actually the resistance the speaker offers to the current that this amplifier can supply. Now, in an audio system, the output current is alternating. It's AC. It's not direct. It's not DC like from a battery. and therefore they call the resistance not resistance, but they call it impedance. But it's also measured in ohms, so that is the same, only because of the fact that it's at different frequencies, the resistance is called impedance. Now the impedance is not the same for every frequency. If you look at the picture on the right, you can see in this graph, it goes up a bit, then it goes down, up again here, and then it goes down slightly up. And so it varies with the frequency. In general, the manufacturers state the nominal impedance, like you see in the picture here on the right, 8 ohm, which is the average of the lowest value of the speaker impedance. You can see all that also in the graph. Now, common impedances are 4, 6, 8, or 16 ohm, and they are referred to as low impedance or low Z. So that's also commonly used for these kind of impedances. Oh, sorry. I go too fast here. Yeah. We know low impedance loudspeakers are quite often used in home audio systems, what you have at home, or in pro sound if you have a big concert hall or theater. So those speakers are also directly connected at low impedance to an amplifier. Like you see here on this picture, we have two loudspeakers, two low impedance loudspeakers connected to the 8 ohm input of this mixer amplifier. Now each loudspeaker load is 8 ohm. Now, how can you calculate the power then for these loudspeakers? This is based on Ohm's law. The power is calculated by the voltage squared divided by the impedance. So if you look at this 120 watt amplifier, so the power is 120 watts. On the output, it's connected to an 8 ohm loudspeaker, so that it's made for an 8 ohm output. The voltage on the output will be then 31 volts, as you can see in this equation over here. Now, what happens if you connect multiple loudspeakers to a single low impedance output of the amplifier? Now, the total impedance, if all these loudspeakers have the same impedance, let's say they're all 8 ohm or something like that, you have to calculate the total connected load of this on this amplifier channel. You can do that by this equation. It's the loudspeaker impedance of the individual loudspeaker divided by the number of loudspeakers. So, for instance, we have here 8 ohm loudspeakers we have connected to, then the total load will become not 8 ohm, but it will become 4 ohm for each of these outputs. So the load connected to this amplifier now will get higher. So the lower the impedance gets, the higher the load of this on this amplifier will become. You can see that in this application, or in this equation here. The power is 31 volts squared divided by 4. Now the total connected power to this amplifier is 240 watt. Now be aware, this amplifier is designed to handle 120 watts, so you will be overloading this amplifier now at this stage. Now what happens if you have different impedances, so you have different types of loudspeakers with different impedances? Then the equation looks a little bit different, as you see over here in this example. So let's see if what the total impedance will be. If we have a 4 ohm, 6 ohm, and 8 ohm loudspeaker, then the result of the impedance connected to this amplifier channel will be 1.85 ohm. Now you can imagine the power that you connect now is way higher. It is 520 watts. So be very careful if you are using a low impedance amplifier and you're using low impedance loudspeakers, you want to connect them like this, all to this single output. You might overload the amplifier if it's not matching, if those impedances do not match. What I mean with that is this amplifier is designed for 8 ohm, so it has an 8 ohm output. If you then connect all these loudspeakers with different impedances, you will start to overload the amplifier. Now what happens if you put them then in series, not in parallel, but you wire them in series, then it's pretty easy. You can just add all the impedances together. So you will add, if this is an 8 ohm speaker, then you will add the impedance for each amplifier output. We have connected 2 of these loudspeakers, so that means in total 16 ohm. Now the impedance goes up. That means the total power that you will get out of this amplifier now will be less. And in this case, it will be 60 watts, so half of the power you will get out of it. So be aware of that as well. If you're having loudspeakers, low impedance loudspeakers, and you connect them in series, you will lose the power that your amplifier is designed for. So the disadvantages of low impedance loudspeakers. Yeah, you need thick loudspeaker cables because the currents can become quite high because of the low impedance of the loudspeakers. So the lower the impedance you have, the higher the current. So you have also take into account that you will have cable losses. Long cables, you will have a lot of loss, and your cable losses will increase. You must make sure, like I already explained, you must make sure that your impedance of your amplifier matches the impedance of your loudspeakers. So what does that mean? If you have several loudspeakers that you have to connect in series or in parallel, you have to make calculations for each connection of each amplifier channel. And it's also difficult to install because you cannot, let's say, connect that many loudspeakers to a single line, to a single amplifier output, like I just explained. So you need to install a lot of loudspeaker lines, so a lot of loudspeaker cables, like you see in the picture here on the right. So the installation costs will also be higher. Now, if you look at the 100-volt loudspeaker system, a 100-volt system amplifier has a constant output voltage of 100 volt. So that's easy to remember. What happens in the amplifier? In the amplifier, we will add a step-up transformer. So we have the same amplifier as we used in the example before, 120 watt amplifier, 31 volts at the output, and there we connect this step-up transformer, which will transform the voltage up to 100 volt, so to a higher voltage. And what does that mean for the amplifier, for the loudspeakers? In order to be able to use the same loudspeakers, so the same low impedance loudspeakers, we also need a step-down transformer in that loudspeaker, like you see on the picture here. Depending on the power this loudspeaker can handle, the individual loudspeaker can handle, there's a certain step-down ratio. Like for instance, for the 6-watt loudspeaker, you want to transform the 100 volt down to 7 volt. So it has a ratio of 1 to 0.07. And for the 10-watt loudspeaker, you want to transform it down to 9 volt. So you have a step-down ratio of 1 to 0.09. So the transformer, the size of the transformer, depends on the power that the loudspeaker can handle, right? Now the impedance of the loudspeaker at the 100-volt side increases. So here we're talking about high Z, so high impedance. Yeah, we also know this as 70 volt, 100 volt, constant voltage or distributed system. So that's also for a 100 volt system, you also see these names are also commonly used. Now 70 volts is used mainly in the US because 100 volt exceeds the safety standard, so they think it's not safe. Yeah, I have to admit 100 volt is quite high voltage. So if you have an amplifier with, for instance, an emergency signal on the output, so at full power, then 100 volts can be really harmful. So be careful. Working on 100 volt systems is not without danger. One thing to remember also, if you use a 70 volt output, some of these systems also have a 70 volt output, it is half the power compared to a 100 volt output. So that also means that the sound pressure level that you will have in the end on your loudspeakers also will be reduced with 3 dB. So you have 3 dB less on the output of your loudspeaker. Now some calculations on a 100 volt system, that's easy. It's the same rules apply, of course. You have a 6 watt loudspeaker, so the impedance, let us see, impedance means that you have to use 100 volts squared divided by 6, and then the impedance of this loudspeaker is 1667 ohm. For a 10 watt loudspeaker, same equation, but then divided by 10, the impedance of that loudspeaker on the 100 volt side will be 1000 ohm. So this is a nice way to calculate all these impedances. Now, what is the total loudspeaker impedance in this case? You can use this equation, for instance, and the total will then be 625 ohm of those two speakers connected here in parallel. Now, the loud impedance on the 100 volt side of a 120 watt amplifier will be 83 ohm. So you have the 100 volt squared divided by 120 watt. That will give you a total loud impedance of 83 ohms. So in this case, we have 625 ohm connected. That is safe. So we have enough power on the amplifier side to drive these two loudspeakers. Now, when you design a 100 volt system, there is actually no need to use these complicated calculations, because you can easily calculate the total power of the connected loudspeakers by adding it all up. If you have, for instance, a 6 watt and a 10 watt loudspeaker, like you see here, you know that the total load on the system, on the amplifier, will be 16 watt. So that's easily done. You can just add it all up. Now this must match, of course, the power of the amplifier. So in this case, if you have a 120 watt amplifier, you could connect maybe 12 10 watt loudspeakers. So that's just as an example. You can just add the power of this of these loudspeakers altogether. Also, what you can do, if you have an impedance measurement device, you see here, you can also measure it with a handheld device. Just connect it to the loudspeaker line, and you will see the total power connected to the line, or the impedance connected to the line. And if you know that, if you know the impedance, of course, you can calculate the power. Like you see over here, we have measured 1670 ohm. Then the total power connected on that line will be 100 volt squared divided by this impedance, means that you have approximately 6 watt connected to this loudspeaker line. So very easy to calculate or measure, and you know instantly what the power is that is connected to these loudspeaker lines. Now 100 loudspeaker 100 volt loudspeakers will have a transformer, like I said, and most of these loudspeaker transformers will have tabs on it, so you can reduce the power of that loudspeaker, the power consumption of the loudspeaker. When you reduce want to reduce the power, you just go to the next tab on that transformer. Like you see here on the right, we have 4 tabs: 6 watt, 3 watt, 1.5 watt, and 0.75 watt. So each step down, you will reduce it by 50% the power. What it eventually does on the secondary side of the transformer, the step down voltage will just decrease, right? That's what happens on the secondary side, on the loudspeaker. So it will reduce the power with 50%. Again, if you reduce power with 50%, it will also reduce the sound pressure level that this loudspeaker then can produce with 3 dB. So it will become 3 dB less. If you look at the advantages of 100-volt systems, yeah, there are lower currents. The higher the voltage, the lower the current through these cables. So you can use thin cables. You have less cable losses. You can run longer cable runs. You can connect multiple loudspeakers to a single line. It doesn't matter. You can just add as many loudspeakers you like to one single line up to the moment it reaches the maximum power that the amplifier can deliver. You can also combine different power levels, different impedances, it doesn't matter. You can easily calculate it. It's easily added up, all these powers, or measured if you like. Easy to install, one single line to cover this whole area. And also easy to expand. You can just tap off at any position on the 100-volt loudspeaker line, and you can add an extra loudspeaker if you like. So installation costs are lower compared to a low impedance system. Okay, Martijn, this is what I wanted to tell you today about commercial audio and 100-volt basics. Are there any questions?
Yeah, let's see what questions we have here. Have any yet? Okay. Here is one. So how many of these PLN 6 Z4S can be connected to one panel all-in-one? How many panels can be connected? Maybe you can answer the next question. The difference between, and that's on a call station. Besides then the different connectors, what is the difference between call stations LBB 1950 and the PLE1CS? Another question, maybe that's on the ones, yes. Does a multiple zone setup not complicate things in the supermarket? Can you transmit to all zones at once?
Yeah, you can make all calls. So you can make a call to. It's also depending on your system and the call station you have. But yeah, okay, if you have a call station with different zones, you can connect. You can push all buttons or all call button, and then you make a call to all zones at the same time.
Yeah, depends a little bit. This next question is, I don't know for which system this question is meant, but can the amps handle a mix of low impedance on one channel and 100-volt on another? So
yeah, that's.
I think it's planar matrix then that we talk about.
Also, yeah, but the amplifiers also, like I showed in the picture, have an 8 ohm and a 100-volt output. be aware that that you have to make a calculation on the power you're using then at that time.
Basically, so what you say is when you have a two-zone system, you could also use one output in low Z and the other one in 100 volt.
Yeah, for instance, you could do that. Yeah, they're all active, so you could do that.
Good. Does the planar matrix amps support emergency voice alarm connection? So
planar matrix is not a certified voice alarm system. So yeah, you can put on any system, any audio you like, but it's not certified.
Yeah, so it has an override, 100 volt override input.
So you can use it, but
yeah. But it's a non-certified part of your voice alarm system then. So if you have a yeah, correct.
Yeah.
I think what you when you connect it to a normal announcement system, not in a voice alarm status, then you can use it. When the central system would go in an emergency alarm, then you have to provide things like, for example, a power cutoff of the planar matrix, because you are not allowed to use planar matrix anymore. So you could use it for central announcement, but not as a part of a voice alarm system. Maybe that helps. Will Ethernet solutions, HP over IP, replace or not 100 volt solutions in the future? Okay, so if IP audio solutions will replace 100 volt solutions.
Yeah, that's a good question. For IP audio, it might sound easy, but with voice alarm systems, you need to supervise everything. Yeah? So then it maybe gets more complicated. Yeah, we're just at the beginning of developing these kind of loudspeakers, IP loudspeakers.
With IP loudspeakers, especially in these commercial audio solutions, I think yes, in the future you will see more of that. At this point, especially when you are going to a little bit more sized commercial audio solutions with, let's say, 6 or 8 or 10 speakers, then 100 volt system is still a more cost efficient solution, if I may say so. Because don't forget, with an IP audio speaker, you also need to power it. You need power over Ethernet routers, and also that costs still. And also the speaker itself is not, is also a little bit higher priced than a normal speaker, of course. I think that's something you have to take into account there. Will Ethernet solutions replace? Okay, that was the same question. Somehow came up twice. Can the amps handle a mix? I think that one also had already. Okay. So accidentally it came in twice. What if I add a 480 watt amplifier to a planar all-in-one, and the total loudspeaker load is 480 watt? How does 480 watt for program, 240 watt for BGM sound like?
Well, you will overload the system because the all-in-one has a 240 watt internal amplifier. So I suggest not to do that.
Yeah, if you would use a max of 240 watt, then it would work, right? Then you make it a two-channel system basically.
If you add, but the total power, you have two channels, but two channels have to be used at the full load, right? So if you are playing music in all zones, you use one channel to put the music on the loudspeaker, so it cannot be more than 240 watts.
So you can use a 480 watt amplifier, but you can still use all that 480 watt, 240 watt, because that's the max, the internal amplifier.
Yeah, exactly. Yeah. So it doesn't make sense to use such a high power amplifier.
No. Well, nowadays with availability in the market of amplifiers, it could be an alternative, right? No questions from my side. Can we stream music from an iPad to planar matrix using third-party products?
Yeah, you can do that. But we're gonna talk about that in next week in the next session.
Good. Okay. With that, I think we are at. Let's see, is this? Can we? One more question. Can we configure two PLM wall panels with the same address to use in a big hall? So you would imagine then one at one side of the hall, one at the other side of the hall, and doing exactly the same.
Planar matrix you're talking about?
Yeah.
Yeah, I think that's possible. You can do that.
So basically, the dip switches of the wall panel would be then exactly the same.
Yeah, you will have two wall panels controlling the same thing.
Yeah.
Actually.
You can also do two wall panels with each their own address, which I think is the setup how a system should be set up, and then
That is how
configure
it's
it the
designed.
same way,
Yeah.
right? So that's
Yeah,
I think that's a little bit safer then to
yeah,
prevent.
yeah. Use it as it is designed. So use for each wall panel, it's a unique ID.
Yeah.
Yeah.
Okay. That's
But
all.
okay, that's planar matrix. We'll talk about planar matrix next week.
Yeah. Yeah. Correct. So more in that session, right? I think we had. Did we have one more slide on what's coming up next?
Yes, we have next week the part 2. I already said a couple of times planar matrix. I'm gonna talk about that one.
Okay. Now it's official. Huh? So at
Yeah.
Tuesday, 22nd of Feb, 11 to 12 Central European time. So yeah, hope to see you there again. And thank you guys, and stay safe.